Hello guys! Now we're going to look at an absolute value question together. The question asks, what is the smallest integer value of x? So, when you look at the question, you'll notice that the x's are common, friends, and in fact, you can take the coefficients inside the absolute value out of the absolute value. For example, in this expression, when you take the 3 out, it becomes 3 times the absolute value of x, and friends, the minus 4 also comes out as plus 4. Let's take that out as well. So it becomes 4 times the absolute value of x is less than 28. Notice, aren't the x's common in the absolute values? Then you can collect the coefficients. I've combined them here. It became 7. 7 times the absolute value. X is less than 28. If you simplify it nicely like this, friends, I want to continue from here. The absolute value of x is less than. Friends, it will be 4. Now, you know how we open up the inside of the absolute value as both negative and positive? I'll do the same thing in the inequality. So, friends, this means that the value of x here will be between 4 and minus 4. They've asked for the smallest value of x. In this case, guys, it will be minus 3. Hello, everyone. They've asked what is the smallest value that the expression can take. All right. Now, they want the result to be as small as possible. The question gave the exponent as an absolute value too, right, guys? So what will happen then? Here, the absolute values have to come out as their smallest version. All right. For the value inside the absolute value to be the smallest, friends, it means that the inside of the absolute value must be equal to 0. Okay. What happened? Now we know that x is 0. Now, if you substitute 0 wherever you see x, the other absolute value will give you an expression like this. Okay, when you subtract 3 from 0, it's negative 3 again, right guys? Pay attention. These are inside the absolute value. And the absolute value always comes out as positive, right? I think everyone remembers that. So, what will negative 3 become then? It will become positive 3, the third power of 3. So our result is from the third power. The smallest value will be 27. Hi everyone. X and y are both integers. We're given that the sum of two absolute value expressions is 1. And they're asking us what the product of x and y is. Okay, now guys. One of the results of these two absolute values has to be equal to 0. The other one has to be equal to 1, so that when I add 0 and 1, or 1 and 0, I get 1. Okay, so here's how I'm thinking. If the result of the expression here is 0, okay? Let's assume the result of the expression here comes out as 1. Now, for this part to be 0, I have to set the expression here equal to 0. And for this expression, friends, I have to set it equal to either 1. Sorry, to 1 and minus 1. Alright, so that one of them is 1 and comes out as 1. Now, if I set it equal to 0, let's say 4x plus 8 equals 0. Let's move this to the other side as minus 8. Let's send it over. 4x equals minus 8. I divided minus 8 by 4. X equals minus 2. Is it an integer? Yes. Now, I'm taking this part. 3y minus 13 equals. Let's say it's equal to 1 and see what happens. I moved this to the other side. Plus 13. 3y equals. I added 1 and 13. 14. Look, 14. It's not a multiple of 3. It can't be divided evenly. So, let me even simplify it like this. 3y equals. It came out as 14 over 3. Well, this isn't even an integer, guys. Now, let's set 3y minus 13 equal to minus 1. Let's move this to the other side. Let it be plus 13. 3y equals 12. 12 is a multiple of 3, guys, so it divides evenly. I divided 12 by 3. 4. It's an integer. This is also an integer. Okay, now I've got 2 of them. Let's see. You know, I said the result of this could be 0 and this one could be 1, or vice versa. For example, if the result of this is equal to 1 and the result of this is equal to 0, which is the case I'm going to examine. If you want the result here to be equal to 1, the number inside will either be equal to 1 or equal to minus 1, okay? Let me show you one more so it's easier to understand. Now, let's take for example 4x plus 8. If I set it equal to 1 and move this to the other side, it becomes minus 8, so 4x equals minus 7. Look, 7 isn't a multiple of 4 anyway. If you simplify it like this, the value of x comes out as minus 7 over 4. And that's not an integer. See, it didn't work. Now let's try setting it equal to minus 1 and see if that gives us a value. Let's check together. I set it equal to minus 1. I moved this to the other side. Minus 8 for x equals minus 9. See, again, 9 isn't a multiple of 4. If I simplify it like this, the value of x comes out as minus 9 over 4. That's not an integer either. So, I didn't even need to apply it for this, guys. I mean, there was no need to set it equal to 0. I couldn't find anything from the x's anyway. So what happened? So, in this case, the value of x is equal to minus 2, and the value of y is equal to 4. They asked for their product. From minus 2 times 4, our result is 8.
Hello everyone. We've been given an equation with absolute value. We need to find the solution. First, let's tidy up the equation. Move the 3 as plus 3 and minus 3 to see what happens. In the final step, we have absolute value of 2x plus 1 equals minus 3.
Guys, the absolute value can never be equal to a negative result. In fact, what do we know from the definition of absolute value? The result of the absolute value can be at minimum 0, or it can be an expression greater than 0. In other words, it can be positive. So what happened to the expression here? It said absolute value equals minus 3. So this contradicts the definition of absolute value, doesn't it? That means, since there is no value we can find, therefore, this set will be an empty set.